Hi, everybody. I wanted to do a little explainer video on some ongoing efforts in the continuous integration, continuous deployment world. This is specific to deploying Dockerized applications to internal and live environments. I'm going to share my screen here and walk you through it. So 6 weeks ago or so, I made this video about the Jenkins pipeline library, which is a effort to have a generic library that provides all of the mechanics of doing deployments for repositories using Jenkins and Jenkins, Docker, and GitHub. So this is all going to be done in the context of that, and we are going to assume that the repositories you might want to deploy are following this convention. So just to go through this really quick, our CI/CD conventions here are that you have a GitHub repository with your code that's set up with a webhook to Jenkins. So when you commit into your GitHub repo, that triggers a Jenkins task, which is set up to execute the Jenkins file out of that repository, and that repository performs deployments. Or I should say that Jenkins task performs deployments. The code that's in that repository is configured for Dockerized deployment. So it's got a Docker file, Docker compose file, Jenkins file, and that Jenkins file uses the Jenkins pipeline library and typically would use the API delivery pipeline method. Doesn't necessarily have to, but that's the way that most of these are built right now. And then the Jenkins pipeline library is configured to deploy to dev.ipums.org. That's for the repo's master branch, as well as any development branches. But it's also configured to deploy to an internal server, and that is on the named branch internal, and to the live server, and that's on the Git branch called live. So those are the conventions that we follow. And in order to deploy to internal and to live, you need to use the named branches of internal and live. So just to kind of describe this visually, this is the strategy. This is a diagram of a Git repo, and what you see here, this is going from left to right, and is time. Each one of these dots is a check-in. We have 3 named branches: master, internal, and live. You'll see that there's also these blue and green branches. These are development branches. They are branched from master. Check-ins are made on them. They're reviewed and then merged back into master. So the idea of the Jenkins library is that each one of these check-ins on both master and the development branch get deployed to dev.ipums.org. So you see each one of these dots is a commit point. That commit point triggers the webhook, which goes to Jenkins. Jenkins kicks off the task and deploys to dev.ipums.org. But we have these special branches down here, internal and live, and the Jenkins pipeline library is configured to deploy those differently. They're separate servers, and the Jenkins library is configured as such to push to those machines and deploy containerized apps to both internal and live that way. The important thing to mention here is that the way the mechanics of how we deploy to internal are really distilled down to just a git merge. In the case of internal, you are merging master into internal. In the case of live, you're merging internal into live. I think I just got those words right. To deploy to live, you are merging internal into live, and to deploy to internal, you are merging master into internal. So just to kind of review that whole idea there, So after all the groundwork is laid, the deployment to these environments involves one step, which is merging from that base branch into the target branch. That's either master into internal or internal into live. Everything else is automated. So really the only task we've got here is doing that merge to make that deployment happen. The reason that it's so simple is the expectation is that all the code reviews have been done on development branches, and those PRs are then merged into master. And if you have any further testing, you're going to do that on the master branch on dev.ipms.org. You're going to confirm everything works the way you want it to, and then the deployment to internal should be as simple as doing that merge. Now, we've been doing this kind of merge with the GitHub web UI. You can also do this from the command line, but the web UI in particular is somewhat problematic for this. There's more than one place when you're clicking through that merge where the wrong choice can actually lead to something you don't want. For example, if you are trying to merge internal into live and you've accidentally flipped them, which is very easy to do, and you merge live into internal. This is not what we want. We don't want a UI where a simple mistake can lead to bad things. Also, in the case of microservice APIs like ISRDI, we have 4 APIs that work together. And if you're going to do a deployment, typically that's all 4 APIs. Well, if the GitHub web UI requires 4 to 6 clicks to get through, you've got to do that times 4 every time you want to do a deployment. And that can be pretty tedious. And also, like we've already said, kind of error prone. So with that, I decided that the best approach might be a Slack app to interact with GitHub and cover these deployments. And without further ado, I'm going to just demo that. If I can get this Zoom thing just to get out of my way. There we go. Okay, so here we are in Slack. I have written this deploy, it's called the ISRDI-Deploybot, and it is invoked through a / command. So here I am in the general channel. If I type deploy, you will see the help message for deploy, which you give repositories and an environment on the command line, and it will manage your deployment. Now, we don't want this to be invoked anywhere, so if I were to just enter deploy here, it will give you a message that says this command can only be invoked from the channel bot deploy. Okay, let's go over there. Here we are in bot deploy. Let's do this again. Same command, don't give any arguments. And it gives you a response, specify at least 1 repository and exactly 1 environment. Okay, let's do that. So I'm going to give a fake repository name here. I'm just going to say foobar, and for an environmental, we'll just say internal. Now, when I do this, it will say, you want to deploy the repo foobar to internal. Is this correct? Well, this is going to fail because there's no repo called foobar. Let's go ahead and try it, though. We deploy it, and foobar merge aborted, not found. Okay, good enough. So now let's try to deploy a real repo, ipms config, but we're going to give it a branch that doesn't exist. Say foobar on this one. And it's going to say deploy to the environment foobar ipms config, and you say sure. This is also going to fail because that branch doesn't exist. You can specify more than 1 repo. And you'll say deploy to internal, and it will list you the repos, and we can say deploy, and in this case it's going to say, again, not found because those don't exist. Further, I have enabled this bot to have pre-configured repo groups. Right now there's only one of them because there's only one that I know about, and that's ISRDI APIs. So this is a name that I made. It's not a repo name, it's a group name. This is actually part of the bot code. So if I say ISRDI APIs and say internal, that will explode into the 4 repos that are part of that repo group. In this case, I don't want to do this deployment, so I'm just going to hit cancel, and that will remove the message. So that kind of goes over the various options you've got with the deploy command. I wanted to show you a real one, though, in action. So what I'll do is I'm going to tile this. Here I am in the IPMS config repo, just a small repo that we use for microdata configuration. And I have gone ahead and added this internal branch, which you'll notice says this branch is even with master. So what I'm going to do actually is go over to master, and I'm going to fake like we've just made a merge from a development branch into master. And an easy way to do that is just alter your README command or your README doc. So down at the bottom, I'm going to say this is a test of the ISRDI Deploybot code. I'm going to commit that. Okay, so now I've committed that to master. And sure enough, if I go over here and check out internal, it will say we're 1 commit behind master. So now let's go back to the deploybot and say deploy r: IPMS config to internal. So this is what we want to do. We want to merge master into internal, and you do that by specifying the name of the repo and saying the environment is internal. Now it's saying, would you like to do this? And I'm going to go ahead and say deploy. And look at that, it worked. Check mark, IPMS config merge of master into internal completed. And it even gives you this nice link where when I click on it, it will actually take you right to the merge for that repo. And it will show you exactly what changed in that merge. Pretty slick. If you do multiple repos, you'll get multiple messages back. If some of them work and some of them fail, you'll get check marks by the ones that work and failure messages by the ones that don't. I will show you now, if I do the same thing on the same repo, that is, try to do another merge, and I say this one will also fail because they're identical. And I think that pretty much covers the ground here. The idea is that we can use this deploybot to very quickly send out deployments to our non-dev environments pretty safely with good error messaging. And that is all I have to say on the subject. Let me know if you have any questions, and if when using this you feel like it should be extended in one way or another, I'm happy to give it a second look.